All right. So happy Monday or Wednesday, not Monday. Let's not live Monday over again. But happy Wednesday. We are almost halfway through our week and hopefully halfway through the remote learning. Tomorrow night, board meeting, we find out that maybe we get to go hybrid, which would be a definite step in the right direction for us to get back in the classroom. Just a little bit about this week, what's going on with this week, the rest of the week. We are going to review today, and tomorrow you're going to take a quiz on the first 4 sections of Chapter 2. So we're going to look at kind of reviewing the slope, reviewing a function, why something is a function versus it not being a function, kind of go over the domain and the range, what that means. So CAD terms we talked about on last week when we started the section 2.1. So that would have been like last Tuesday or Wednesday. We're going to look at first though, before we do a little bit of review for the quiz on or tomorrow, we're going to look at number 41. And this was the only question pretty much that people got stuck on. That was from the homework yesterday. So yesterday, remember, we talked about writing equations of lines, we talked about parallel perpendicular lines, looked at 2 word problems, and then also talked about that direct variation. So we are going to look at number 41. So if you want to take out your homework and also look at 41 with me, it says to write an equation in standard form. In the standard form of an equation, a line is ax plus by equals c. There's 2 ways we can write a line. We can write it in the form y equals mx plus b, and we can write it in the form of ax plus by equals c. So we really can write an equation in 2 different ways. So we're going to see if we can try and take this equation and write it in a specific form. It says the sound is glitchy and in and out really bad. I apologize for the sound. I thought I'd try something different today. How does it sound back there? I'll try it a little longer. If you're noticing something that it doesn't sound like it's going well, let me know. But I'm trying to use the smartboard today instead of using the iPad because if we do go hybrid, we are going to have to use something different. So that is why the sound, I'm hoping it gets a little better. Can anybody say right now, like, thumbs up if it's sounding any better? It's starting to get glitchy.
I don't know if they can see it, but now I also can't see it. It's just a black screen. I can see screen sharing, but not the other.
So you can't see me myself?
No.
Okay. All right, I guess that's okay.
Can anyone see Mrs. Kane?
No.
I can see her now.
Okay. I'm thinking it's the school's wonderful bandwidth. Because I mean, I don't know what else it is. All right. No, I'm really glitchy. Well, hybrid learning could be really fun and exciting if I'm going to be glitchy all the time. All right, I'm going to pull it off the smartboard. I'll set up my iPad. I really wanted to try it this way to see how it would work, but I'll give it a try another time because I want to make sure we get some review done. So we'll just flip to an iPad instead. Kind of work with it a little bit here. You guys are my guinea pigs. I apologize. First period of the day, you get to be guinea pigs. All right, so we are going to look at this question, and we're going to see if we can kind of take what we know from the problem, the information they give us, and try and translate that into what does it mean, and how can we take it and write it in the standard form of the equation that they're asking us for. All right, can you see on my screen now? Still that. All right, there we go. Okay, so we are going to try and create an equation. And that equation for number 41 is supposed to be in that ax plus by equals c form. And then it gives us information about a slope, and it also gives us information about a b value. And it's saying that the slope is 4, and the b value is -3. Am I sounding better? Yes. Okay. So, does anybody know how to start this problem? Like, our end goal is to write an equation in this ax plus by equals c form, but how do you think you'd approach it? Where could we begin using what we're given? Faith, what do you think?
Well, b -3 will go where the c is, because that's the form.
Not necessarily. So if you have an m and a b, can you tell me an equation that we talked about last week and this week that would use an m and a b in the equation?
Slope-intercept form.
Yeah. What does slope-intercept form look like?
Y equals mx plus b.
Okay. So if we take that and plug the numbers into this form, so we're going to get to the standard form in a minute, but we have to use the information that we have and stuff we know. So if we plug those numbers in, Faith, what would it look like?
Y equals 4x plus or -3.
Right, so y equals 4x minus 3. So she was saying that the c value would be -3, but it's not necessarily going to be -3. So if you plug it into first y equals mx plus b, and then pretty much I just start rearranging the problem. So our goal is to have x and y on the left and the number on the right. And in this case, yes, Faith was correct. The number on the right is -3. But if we had fractions in this problem, then that number on the right would not be -3, and we'd have to kind of manipulate those fractions. Now, again, this one, it is exactly what she said. So we're going to take the x on the other side. I'm going to subtract 4x. I have a y, and then it would be equal to -3. So converting it from slope-intercept, and now I have it in standard form. And that's it. So take y equals mx plus b, manipulate the equation, get the x and the y on the one side, and then c is just a number. It doesn't have anything next to it. That's why in this case it happens to be that -3. Questions? That was the only question from the homework. So are there other general questions that you have before we start looking at some review problems? And maybe once we start getting through the review problems, you might come up with some questions. But feel free to send them through the chat or just ask. I want to make sure everybody feels comfortable for tomorrow. Okay, so I am going to go over the review. Oh, sorry. I don't know why I missed it. Oh, here it is. Faith, question? No. Okay. If you want to go into Google Classroom, and the assignment for today is this review worksheet, which covers sections 2.1 to 2.4. This should be posted already available for you in Google Classroom. So see if you can get this out. If you don't want to get it out on your iPad, that's fine. Just grab a piece of paper and you can write down the couple of problems that we kind of go over together so that you have those problems done. And that might be a little easier for you as well, so you don't have to worry about sharing a screen, having two devices up and running. I'm not going to go through every problem with you on this worksheet, but I wanted to kind of highlight a couple of the problems just to give you a little refresher about what it means, what it's asking for, to kind of go over those vocab terms as well. So I want to make sure everybody has this worksheet, or at least take some notes on a separate piece of paper. Always have lined paper with you or some type of paper with you. So the first pair of problems want us to identify the domain and the range of the relation. Remember, a relation is just pairing x and y together. So once I pair an x and a y together, I have a relation. And then it says, tell whether the relation is a function. Not all relations are functions. So we have to kind of think about what it means for it to be a function. But we're going to wait and just talk about the domain and the range. So if we want to first identify the domain, this was one of the vocab terms that we talked about last Wednesday in section 2.1. Can anybody explain what the domain is? And there's a couple of different words we can use for it. So what would you say the domain would be of a graph, of points? Ava, what do you think the domain is?
Is the domain X?
The domain is X. Nice. So the domain is the X. What other word can we use for domain besides X? Or what other word can we use to represent X? There was a couple of different words that we used, and I want to make sure you're thinking about all of them. Jaden, what other words could we use?
The input values.
Yeah, the input. We also said that it was the independent and the control variable. So domain actually has like 4 different things we can think about. It's the X value, it's the input, it's the independent, or it's the control variable. So that represents domain. So let's see if we can identify the domain first. I'm going to put a little d here for the domain. And based off of what Ava said, she said it was the X values. So I'm going to look at my X values, and I see a 1. There's another 1. I don't need to write it twice. I already have a 1 down there. We have a 2, a 3, and a 4. Those will be my X values of this relation. Now, because these X values are a group, we like to group them together in these little squiggly things, which I still enjoy drawing. You might not be very good at drawing them, but something about it I like doing. I don't know why. I'm a little crazy sometimes. But we're putting those together. They're not brackets, but those little squiggly things, whatever they happen to be called. There's probably a fancy name instead of squiggly things. But that shows that they're grouped together. They represent the domain of our relation. All right, so then let's talk about range. That would be our next word. If the domain is the X, the input, the dependent, the control, what would the range be? Ella, do you know what the range would be?
The output value.
Nice, so output. What else could we use instead of output, Ella? Another word maybe? Or what variable would it be?
The dependent variable.
Yeah, nice. Dependent. It makes sense. If X is independent, or the input, the range would be the opposite, the output, or the dependent, or the Y. So those would be the 3 things that we could represent thinking about the range. So looking at this problem, the range would be the y values. I'm going to write them in increasing order. So I know the 3 value is first, but I'm looking at all of my y's, and I see that there's a 1, a 2, a 3, the 5, and the 6. And again, putting them in those little squiggly things kind of says that that is a group of y values together to represent the range. All right, so those are 2 nice vocab terms to talk about. The other vocab term that we talked about was a function. Can anybody remember what it means for a relation to be a function? Alyssa S., what do you think?
Each like X needs to have its own Y, and like they
Oh,
can't share one.
yeah, very nice. I like that. So she said each X has its own Y value. It can't share one. So Alyssa, based off of the definition you gave us, is number 1 a function?
No, because there's 2 ones.
Yeah. So the X value of 1 is paired with a 3, and the X value of 1 is paired with a 1. So you could say the X value of 1 is repeated or shared. Or you could say each X has multiple Y values instead of its own Y value. So that's a really good review of those terms. So domain, range, function. 3 and 4 ask you to use the vertical line test. Remember, that's just drawing vertical lines and making sure your vertical line passes through your graph once. If it passes through the graph once, it's a function. If it passes through your graph more than once, it's not a function. So the vertical line test, just drawing vertical lines, does it cross through your graph at one point? It's a function. Does it cross through the graph more than one point? Not a function. So I'm not going to go over those. But I did want to talk about 5 and 6 because when we had this as a homework assignment, there were a lot of questions on these types of problems. So this says tell whether the function is linear. Of course, it says explain, and then evaluate the function for the given value of x. So we've talked about domain, range, function, and now we have this word linear, a linear function. So if we have a linear function, Julia, what would a linear function look like?
Would it be in like nx plus b form?
Exactly, yeah. So if we have a linear function, whoop, so f of x equals mx plus b. Remember, once we say something is a function, then we write it in a certain form. So it's a function f of x when it's in mx plus b form. So is number 5 a function? Lacey, what do you think? Is number 5 a linear function?
Yes.
Yes. Say it with confidence. Yes. Why, Lacey?
Well, because it's in like the mx plus b form.
Yeah, sure. We could rewrite it as negative 2x plus 5. Then right here is mx plus b. Lacey, is number 6 a linear function?
No,
Why not?
it's not in that form.
Yeah, it's not in that form. It has that x squared, which we're going to talk about in chapter 4. Not linear. Now, there is a second part to this. It says evaluate. That means find a number, find a numerical answer. Evaluate the function for the given value of x. So if I look at number 5, they're giving us a negative 2. Remember, that number inside the parentheses represents x, f of x. So whatever's in the parentheses is our x variable. So we're going to plug it into the function wherever we see an x. So if I simplify, that's pretty much what evaluate means. I would end up having 5 plus 4, which makes 9. So I have f of negative 2 equals 9. Now remember, you're not dividing anything here. This part on the left is notation. It tells me my x value is negative 2. The answer you get out is your y value. It's a different way of writing a point. So f of negative 2, when x is negative 2, my y value is 9, or my output is 9. Questions? All right, I'm going to go over 2 more problems with you. So I'm trying to hit a couple of different types. 7, 8, and 9 are slope. I'm hoping that everybody's okay with slope because I'm going to skip 7, 8, and 9. But 10 and 11 are application problems of slope. And I love application problems because it makes you go a little above and beyond and not just calculate the slope, but see if you can apply the slope in some type of way. So I like this pair of problems because it actually gives you the slope and it asks you to find a k value. And the k value represents a value in the ordered pair. So if you look at number 10, it says find the value of k that satisfies the given slope. Well, I have an x1 and a y1. My second point would be x2, y2. So that k value is representing my second y. And then we're given the slope. So our goal is to figure out k. Instead of finding slope, now we want to figure out this k value. How do you think you would do that? So always take what you know or use what you know in the equation. Alyssa, what do you think?
You would use the formula m equals y2 minus y1 over x2 minus x1 and just plug in the values.
Awesome, nice job. So plug in everything that you know. That's what a formula is for. We know the slope this time. Instead of finding it, we know it's negative 3, so let's plug it in. We don't know y2, but I know that it's k, so I'm going to use a k in the problem there. Minus y1. And then I have x2 minus x1. Now I'm going to place this negative 3. I'm going to make it a fraction as well, just that I'm looking at a fraction equal to a fraction. So we can do a little simplifying here. We have negative 3 over 1 equals k minus 1. And if I combine the denominator, 4 minus 6 is negative 2. How would you solve for k? That's what we need. We need to get k by itself. We're trying to find the k value. This is now an equation. How would you solve this equation? Maddie, do you have an idea of what we could do to try and solve this equation to get the k by itself?
You could multiply it by negative 2 on, I think it would be the left side. I'm not sure.
You're right. So we want to get the negative 2 out of the denominator. Right now we're dividing by 2. The opposite is to multiply. So a little whoosh action there takes that away. And on the other side, if you're multiplying, that gives us a 6. So then Maddie, k is equal to?
7.
7, yeah. So k is 7. I now know that that ordered pair is 4, 7. You could check your work by using the slope formula. Now that I know k is 7, I could take 7 minus 1, y2 minus y1, x2 minus x1. Oops. Oh, no, that's right. And then I end up having a 6 over negative 2, which better equal negative 3, which is my slope. So this here is just like a little check step. I'm showing you how it works, or why it works. Any questions on that? That's a different way of trying to find a slope, or having a slope and trying to find a missing piece. So again, it's applying what you know about slope. taking it a little bit above and beyond. All right, there's one more problem that I wanted to go over. So looking at the next group of problems, you're determining if the lines are parallel, perpendicular, or neither, again using slope. So there's a lot of concepts talking about slope. And then I have some problems talking about x and y intercepts. And I wanted to go over one of these with you just to give you a refresher about finding the slope, finding the y-intercept, finding the x-intercept. So we know that the slope is m. We know the y-intercept is b. Or we could also say the y-intercept is when x equals 0. Depending on what we're given, the y-intercept can be thought of in two different ways. The x-intercept we have to find when y is equal to 0. That's never in the equation. The x-intercept you always have to calculate. So in number 14, it wants you to graph the equation. It wants you to identify the slope, the y-intercept, and the x-intercept. And I'm actually going to identify the stuff first, and then we'll graph it. So, Valerio, what would the slope be of number 14?
3,
3. The y-intercept is
2,
2. How would we typically write a y-intercept? Since it's a point on the graph, how could I write that?
0, 2.
Yeah, 0, 2. And then if we want to find the x-intercept, what would we do with the equation up above to find the x-intercept? If I wanted you to show some work to find it, calculate it.
Plug 0 in for y.
Yeah, so we're going to plug 0 in for y, and then solve for x. So Valerio, x would be
Negative 2/3.
perfect. And then again, we're writing that as an ordered pair. So intercepts are points on the graph. They're ordered pairs to represent when the graph crosses the x or the y axis at a specific point. So the last thing we're going to do is just graph this. It is in slope-intercept form, so I could graph it in the form that it's listed in, or I could graph it by plotting the x and the y-intercept and connecting those points. But I'll graph it with the mx plus b form. So we have mx plus b is 2. And then the slope is 3 over 1, which means I should rise 3 and run 1, or I could fall 3 and go backwards 1. I'm going to go backwards since that's the space on the graph that I'm given. So my line should match the information that we have listed below. And if I'm looking, I have a slope of 3. It crosses the y-axis at 0, 2, and it crosses the x-axis probably at about negative 2/3. Questions? So I'm going to stop talking, and I'm going to give you some time. You got about 11 minutes to continue working on this review. We did a good number of problems together, so hopefully that gives you a little refresher. I didn't go over any of the problems of writing the equations of lines since we just did that yesterday and on Monday. But I'm going to stick around here. So if you want to continue to stay on with me, you can. And if you have a question, feel free to ask, just like you would be in class. You'd be working on this, and I'd be walking around. So you can continue to work on these and ask me questions as you get stuck on something. Or if you'd like, you can say, Mrs. Kane, I'm just going to get off my device right now, and I'm going to just work on it separately on the side. Totally up to you. Questions? Tomorrow you have a quiz. You're going to come see me really quickly, and I'm going to say hi, and I'm going to send you off on your quiz, and I'm going to show you where it is. But I won't be taking any questions tomorrow because I want to make sure you have the entire length of time for a quiz. So if you do have questions, please email me, and I will respond back to you. I can schedule a Zoom with you if you feel like you have a lot of questions, or I can try and answer them through email or through a little short video of me recording myself and sending it back to you. All right, I'm done talking. If you have a question, let me know. I will see you tomorrow. Same time, same place, 8:30. We'll get you started on that quiz then.